Armand Fizeau was an experimental physicist in Paris. His specialty was actually refining and confirming other people's results. And this might sound like a bit of an also-ran, but in fact this is the soul of science, because there is no such thing as a fact that cannot be independently corroborated. And he was familiar with Galileo's experiments in trying to determine whether or not light had a speed. So Galileo had worked out this really wonderful experiment where he and his assistant had a lamp. Each one was holding a lamp, and Galileo would open his lamp, and his assistant would open his lamp. And they got the timing down really good. They just knew their timing. And then they stood at two hilltops 2 miles distant. And they did the same thing on the assumption from Galileo that if light had a discernible speed, he'd notice a delay in the light coming back from his assistant's lamp. But light was too fast for Galileo. He was off by several orders of magnitude when he assumed that light was roughly 10 times as fast as the speed of sound. Fizeau was aware of this experiment. He lived in Paris, and he set up 2 experimental stations roughly 5.5 miles distant in Paris. And he solved this problem of Galileo's, and he did it with a really relatively trivial piece of equipment. He did it with one of these. I'm going to put away the clicker for a second because I want to engage your brains in this. Now, this is a toothed wheel. It's got a bunch of notches, and it's got a bunch of teeth. This was Fizeau's solution to sending discrete pulses of light. He put a beam behind one of these notches. If I point a beam through this notch at a mirror 5 miles away, that beam is bouncing off the mirror and coming back to me through this notch. But something interesting happens. As he spins the wheel faster, he notices that it seems like a door is starting to close on the light beam that's coming back to his eye. Why is that? It's because the pulse of light, it's not coming back through the same notch. It's actually hitting a tooth. And he spins the wheel fast enough, and he fully occludes the light. And then, based on the distance between the 2 stations, and the speed of his wheel, and the number of notches in the wheel, he calculates the speed of light to within 2% of its actual value. And he does this in 1849.